Um, so if air leaks in here, then ethanol can be oxidized. Ethanol, the formula, do you know what the formula for ethanol is? Ethanol is CH3CH2OH. In organic nomenclature, F means 2 carbons. So there are 2 carbons here, and then we fill it in, the rest of the structure. And so the ethanol reacts with the air. It doesn't react with, air is a mixture. It reacts with what in air? What does air supply? Oxygen. And oxygen is a great oxidizer, of course. That's why, some wines, in fact, I think all wines, have you ever heard of sulfites? They put sulfites in wine. Do you know why? Well, one thing is, what is sulfite? Sulfite, what's the formula for sulfite? This will be an aside. SO3, and the charge? 2 minus. When we analyze sulfite, oxygen's at a -2, so, we have the net charge here, and then we have the oxidation state. So let's take a look at the oxidation state. We did -2 on oxygen, so -2, I'll write parentheses here, that's for oxygen's oxidation state here. What is sulfur's oxidation state? Sulfur is going to be 4. So we write +4 here. That's the oxidation state of sulfur. I wrote a numeral here to give you some variety. Which means, the charge on sulfur ranges from what to what? -2 to +6. And so different things can happen. So for example, this sulfur is capable of taking electrons. So sulfite could be termed as a oxidizing agent because oxidizing agents take electrons. And so it could take electrons, or sulfite could actually lose electrons. How many more electrons could it lose? Well, right now it's in +4, but it can go all the way to +6. Does everybody see how you get that off the periodic table? Okay. And so sulfite is capable of losing 2 electrons on the sulfur. And that's the property that sulfites are. Sulfites are called antioxidant. Antioxidant is a compound that you put in there as a sacrificial, we don't want to oxidize the ethanol, so we got to put in something that's easier to oxidize than ethanol. What's easier to oxidize than ethanol? Sulfite. So if sulfite's easier to oxidize than ethanol, then sulfite will be oxidized and converted into what? When sulfite gets oxidized, it's converted into, what would you guess? So if it's capable of losing 2 electrons, we go from sulfur +4 to sulfur +6. Where have you seen sulfur +6 before? Or in other words, what has more oxygens than sulfite? Sulfate. So it gets oxidized to sulfate. So sulfite gets converted to sulfate. And then in sulfate, sulfur is +6. And so we'll call this is an antioxidant. As long as this is easier to oxidize than this, that is, as long as this is a better reducing agent than this, then this will be oxidized rather than that. That's what antioxidants are all about. Antioxidants, when you take antioxidants, you want to make sure the antioxidants are easier to oxidize than whatever else you're trying to protect from oxidation. And so these are additives that are put in there. Well, whatever, this wine, did I tell you, I talked about the wine I bought, right? This wine I bought, it contained sulfites. So it must have already oxidized all the sulfites. How much sulfite are they going to dump in there? Are they going to dump in lots and lots of salt? No, because it's going to alter, and people are going to complain, there's too many sulfites in there. So they've just put in a little bit, depending on how much air leaks in naturally, right? But what had happened to my wine was too much air leaked in there, which killed all the sulfite We call that a limiting reagent because you can't put an infinite amount of sulfite, so eventually that sulfite is going to be completely oxidized. Once all that sulfite is completely oxidized, it's sulfate. Can we oxidize sulfate anymore? No, it's already +6, so what's the next thing oxygen is going to attack? The next thing oxygen is going to attack will be ethanol. And so that's what's happened. What happened to my wine was that all this was eaten up. This is the topic of something that's important in chemistry is like, how much sulfite should you put in there? Well, you got to kind of predict, how much air is going to leak in there and how much, to make sure that you take care of all the air that leaks in there, right? And that topic is called stoichiometry. We're going to do that topic next. I think that's the next chapter. And so we can do these calculations to figure out, about how much we should add in there. But apparently it wasn't enough for this because the corks were bad. And so I think the corks were bad. There was a lot of air leaking in, so the ethanol got oxidized. What did it get oxidized to? It didn't get oxidized to CO2. It got oxidized to acetic acid. And so this converted to acetic acid. And so what I want you to do is I want you to use a combination of the chart plus the skeleton redox to come up with a balanced chemical equation for the oxidation of ethanol to acetic acid by air. Okay, so why don't you work on that right now? I'll put up the chart again. And then I need to take a roll. So this is going to be a combination of a chart and this is not a single replacement type reaction. It might look like a single replacement type reaction. O2 plus, so this would be our A plus BX maybe, but this is not an ionic compound in that sense. So it might have that form, O2 plus CH3, CH2, OH. Some people, this is not hydroxide. This is not some cation plus hydroxide. This is ethanol, which is organic molecule. And so I wouldn't treat this as A plus BX because what is the cation B? What's the anion X? Even though it kind of fits that form, right? Not only that, A is supposed to be a reducer. Reducers are on the left side, not the right side of the periodic table. Oxygen's on the right side of the periodic table, so it's likely that the single replacement method's going to fail. I talked about that? Maybe you reviewed it, or maybe you don't have to review it. You don't have to review. You don't have to know the exceptions to the single replacement if you just use the chart method. Well, anyway, give it a go. See if you can write the balanced equation. For this. Of course, when we do redox, what's the first thing we do? When we do redox using the chart method, what's the first thing we do? Inventory. So why don't you start with the inventory and then work your way down? What's the strongest oxidizer? What's the strongest reducer in the inventory? We aren't going to worry about the other components of wine. We're just going to think of wine as being water, ethanol, and that's it. And then you got the air in there, O2. Water, ethanol, and air. Stop this. So work on that.